In the last part of this lesson, we're going to be looking at how do we calculate the arc length. And we're going to again be using the idea that we have the radius and then our angle, which has to be measured in radians. And that's going to be an important piece here. Here's the equation we just saw. S being the arc length is going to equal our angle in radians times our radius. So we have the tire of a car. It's going to make 653 complete rotations in 1 minute. The diameter is 0.65 meters. We can use that to find radius. And to the nearest meter, how far does the car travel in 1 second? Radius is easy. I'm just going to take the diameter divided by 2, and I get this for our radius of our tire. Finding theta is a little bit trickier. We're going to use proportions here. We know that, well, we want to find how many radians it goes in 1 second. So think of it this way. If this is our tire and it's rolling this far, or this direction, we want to know how much of the tire right here is touching the ground in 1 second. So we need to figure out this angle, and that's our theta. Now we know that it goes 653 complete rotations. Now 1 complete rotation is 2 pi. All the way around is 2 pi radians in 1 minute, or in our case, 60 seconds. Now, since this is a proportion, I can think about, well, how do I get from 60 to 1? I divide it by 60. So I can do that in the numerator as well. And when I divide over here, I'm just going to simplify. And I'm going to leave it as 653 pi over 30 radians. That's how far, or how much of an angle it's going to move in 1 second. So now I'm going to use my equation. The arc length is going to equal theta times r, the radius. And so theta is going to be 653 pi over 30 radians times our radius of 0.325 meters. And this is going to give us 22.22 meters, or you could just round it to 22.2. But that's what we end up getting. And keep in mind, is this a reasonable number for how far the car can go in 1 second? And yeah, it does seem reasonable. Here we have a problem with Big Ben's clock tower in London. I drew a picture here. It says the arm is 14 feet long, and we're trying to figure out how far does it travel, this arc length, in 1 minute. So we already know our radius is 14 feet. We need to figure out theta, or in other words, the angle in radians it goes in 1 minute. Now we know that it goes all the way around the circle once in 1 hour. So we know that it goes 2 pi radians all the way around is 2 pi in 60 minutes. And so again, we're going to use a proportion here to figure out how far it goes, or what the angle is in radians for 1 minute. My proportion I can divide by 60, and 2 pi divided by 60 is just going to be pi over 30. So going back to our equation, the arc angle, or arc distance, is going to be our theta, our angle in radians, times our radius. And so that's going to be pi over 30 times 14. We end up with that arc length to be about, we're going to round here to 1.5 feet. So this is how far the hand of the clock is traveling in 1 minute.